Up until this point, most of the series that we've focused on have been series whose terms are all positive. In fact, most of the tests that we've looked at for determining whether a series converges or diverges require that the terms of the series be positive, otherwise the test doesn't work. What do we do when a series has both positive and negative terms? In other words, instead of adding up a bunch of positive values, you're sometimes adding and sometimes subtracting things. Will you end up with a finite sum in the end? Depends on the series. A special kind of series whose terms are sometimes positive and sometimes negative is an alternating series. This is very simple. It's simply a series where the terms alternate positive, negative, positive, negative. So rather than have a handful of positive terms and then a handful of negative terms, you'll specifically have one positive, then one negative, then one positive, then one negative in a very regular pattern. These can always be written in the form, the sum as n goes from 1 to infinity, of -1 to the n times some positive bn. In other words, we get, well, when n is 1, then -1 to the 1 is negative. So we'll have negative b1, then we'll have plus b2, then minus b3, then plus b4, minus b5, plus b6, minus b7, and so on. Or you could start with a positive term instead, and the way to represent that would be to take the -1 to the n minus 1 power, and that will simply swap which terms are positive, which terms are negative. So you'll have, if n starts at 1, n minus 1, 1 minus 1 is 0, so -1 to the 0 is positive 1. That'll be positive b1, minus b2, plus b3, minus b4, plus b5, minus b6, plus, etc. So either way, these represent alternating series. If we think of the bn's as the positive, the absolute values of those terms, then you're going to alternate adding and subtracting each one. Whether you start with a positive or negative doesn't really matter. It's still an alternating series. Let's look at some examples. Here's an example. The sum as n goes from 1 to infinity of -1 to the power of n minus 1 times the natural log of n over n. So let's write out the first few terms so we understand this here. So our n starts at 1, so -1 to the 1 minus 1 power. Again, 1 minus 1 is 0, so we have -1 to the 0 power. That's positive. And we're going to have the natural log of 1 over 1. Next, n becomes 2. Now, 2 minus 1 is 1, so we have -1 to the 1 power, which is negative, and we'll have the natural log of 2 over 2. Then we'll have plus the natural log of 3 over 3, minus the natural log of 4 over 4, plus the natural log of 5 over 5, minus, and so on. And let's maybe try and simplify these terms here a little bit. So the natural log of 1, what power can I put on e to get 1? Well, the answer is 0. So this actually is 0. It is okay for some of your terms to be 0. That's fine. Minus the natural log of 2 over 2. Now, I don't know exactly what that is. I could get a decimal approximation if I wanted to. But notice that the natural log of 2, what power can I put on e to get 2? Well, e is about 2.718. So 2 is less than e, but still positive. In fact, still greater than 1. The power I'd have to put on e to get 2 is a power that is less than 1, but still positive. Which means that, ignoring that negative there, the natural log of 2 over 2 will be a positive number that is less than 1/2. Now we're adding the natural log of 3 over 3. What is the natural log of 3? Well, e is about 2.718. What power can I put on e to get 3? The power ought to be just a tiny bit bigger than 1. So what we'll have here is a number that is just a little bit bigger than 1/3. Just a little bigger than 1/3. And we can keep doing this for the rest. right? Maybe let's just actually write out some approximate values, some decimal approximations for these, just so we get a sense. So we're going to have just 0 minus, let's see, minus 0.347, that's the natural log of 2 over 2 approximately, plus 0.366, the natural log of 3 over 3. It's just a teensy bit over a third. So there we go. Minus 0.347 again, plus 0.322, minus 0.299, plus etc. It's really hard to tell what's actually happening with this series. Is the series converging or diverging? It's really hard to tell. It looks like the terms, after the first few that seem to kind of go up and then down again, the terms start to decrease, it seems. Are they going to keep decreasing? We're not really sure. Are they going to approach 0? Also not really sure. It's really hard to tell from this whether this series converges or diverges, but it clearly is an alternating series because except for that -1 to the n minus 1 power, the natural log of n over n is positive. Of course, bear in mind the natural log function gives you a negative if you plug in a number less than 1, but we're starting with n equal to 1, so we're fine. Our natural log is always positive, and so is the n. So we do have an alternating series here. No idea if it converges or diverges. Here's another example. The sum as n goes from 1 to infinity of n times the cosine of pi n. Now, we don't see an expression -1 to a power here. So is it really an alternating series? Well, the question is, what is the cosine of pi n for any n? Let's write out some terms again. So n starts at 1, so we're going to have 1 times the cosine of pi plus 2 times the cosine of 2 pi plus 3 times the cosine of 3 pi plus 4 cosine 4 pi plus etc. Let's work out what these actually are. We could draw ourselves a quick little unit circle here. Here's a unit circle. Now, where's pi on the unit circle? It's right over here. Pi is this angle that sticks out to the left. That's pi. What is the cosine of pi? Cosine of pi is the horizontal distance, this position here, and that distance is -1. So we actually have -1. Now, we're going to look at the cosine of 2 pi, so if you start here at 0, pi is 1/2 the circle, 2 pi is twice the circle, so here's 2 pi, not equal to 0, but the same position on the circle, it's out here. And what is the cosine of this? That's +1, so we're going to have plus 2 times that is 2. Now we've got cosine 3 pi. 3 pi puts us back over here. And the cosine is -1. So we're going to have -3. Now 4 cosine 4 pi. Well, 4 pi puts us back at the positive side of the circle. The cosine of 4 pi is +1, so +4. Then we'll have -5 plus 6 minus 7 plus 8 minus etc. So that cosine of n pi is really an alternate way of expressing -1 to the n power. It's a way of getting us an alternating series because each integer value of n is going to swap the sign from positive to negative, and so on. So this is an alternating series. How about this example? The sum as n goes from 1 to infinity of cosine of n over n. Doesn't seem that different from the previous series. Obviously, we're dividing by n instead of multiplying by n, but we have a cosine in here still. So is it still an alternating series? To save time, I've written out the first few terms. So these are approximate values here. I wanted to get a decimal approximation so that we get a real idea of what's positive, what's negative. So when n is 1, the cosine of 1 radian, don't forget, we're working in radians here. The cosine of 1 radian is a positive number. It's about 0.540. And then that gets divided by 1. Now the cosine of 2 radians is negative 0.416 approximately. It's negative, so we're ending up subtracting here, and then dividing that by 2. The cosine of 3 radians is also negative, and that's going to be about negative 0.989 divided by 3. And the cosine of 4 radians is again negative. Then the cosine of 5 radians becomes positive, and so on. Let's actually highlight which of these terms are negative and which ones are positive. I'm going to highlight the positive ones in green. So we've got a positive term here. We've got a positive term. The 5th term is positive. The 6th term is positive. The 7th term is positive. And meanwhile, the 2nd, 3rd, and 4th terms are negative. And the 8th term is negative. 9th term is negative. 10th term is negative. So this is not exactly an alternating series because we're not swapping back and forth positive, negative every time. Now the fact is that if you had a series in which there were a fixed number of positive terms followed by the same number of negative terms and then the same number of positive terms and so on, say you had 5 positive terms, 5 negative terms, 5 positive terms, 5 negative terms, and so on, all the way down, then you could actually get away with treating it like an alternating series, and most of the theorems that work for alternating series would actually work in that case. The trouble here is that we don't actually have a consistent pattern, right? Ignoring that first term, which was positive, we then have 3 negative terms, then 3 positive terms, then 3 negative terms. Does that pattern continue? Well, the next term is positive. So is the next term. So is the next term. But, the next term's also positive. That was 4 positive terms in a row. Now the next 3 terms are negative. The next term's positive, and actually the next 3 terms will be positive. So that's positive, positive. And the next 3 terms will end up being negative. And actually what's going to happen with this series is that you're going to have, most of the time, you'll have 3 negative terms, 3 positive terms, 3 negative terms, 3 positive terms. But every once in a while, you'll get a 4th term in there that's either positive or negative. That pattern breaks, and the pattern does not work consistently. And it will actually always break down in a very irregular way. You can't even find a sort of a meta pattern. The reason for this is because pi is irrational. Let's look at a unit circle so we can see why this is happening. So 0 radians is over here on the positive axis. In fact, anywhere along any part of this, our cosine is positive because the x-coordinate of our point will be positive. Now, pi, for reference, is over here. Here's pi. Approximately, but not exactly, 3.14. We could, of course, expand that more. But any angle that lands us anywhere along this part of the curve will give us a negative result for the cosine, right? So I want to work out where 1 radian is, but first I want to figure out where 3 radians is. So 3.14 radians is exactly over here on the negative x-axis. So 3 radians is a little bit less than that. It should be slightly closer to the 0. Here's 3. 3 radians has a negative cosine. In fact, a negative cosine right here of about negative 0.989. Very, very close to 1, as you can see, close to negative 1, which you can see because the horizontal position of that point is pretty close to negative 1. So 2 radians is, well, about a third of this piece here would be 1 radian. So 2 radians is about here. Here's 2. And the cosine there should be negative, but closer to 0, and in fact it is, negative 0.416. Now 1 radian is 1/3 of 3, so that's going to be over here somewhere. And that gives us a positive cosine, about 0.54. There we go, right? So we can keep going. We'll just keep adding 1 radian. Bear in mind, 1 radian is a little bit less than pi over 3. Now, pi over 3 is 1/6 of the circle. So 1 radian is less than 1/6 of the circle, which makes sense because the whole circle is about 6.28. It's 2 pi, right? So here is 4. Here is 5. Here is 6. Here is 7, which is not quite as far around the circle as 1, because you'd have to take 1 plus 2 pi to get exactly back to where you were at 1, and 7 is less than that. Here is 8. Here's 9. 9 is less than 3 pi, so it lands us over here somewhere. Here is 10. And 11 puts us just barely onto the positive side. And this is the important point here. Because the 11 is just barely on the positive side, there's enough room on that positive half of the circle to actually fit 4 line segments, to get 4 angles in. So we're going to have 11, we're going to have 12, we're going to have 13, and we're going to have 14 in here. And that's why we ended up with 4 angles in a row, 4 terms in a row that were positive. And this is going to keep happening because 3 is a little bit less than pi, and pi is irrational. What's going to keep happening is most of the time you're going to have 3 angles that land you on the negative side of the circle, and then 3 angles that land you on the positive side of the circle. But every few times around, you're going to have a little blip there where you actually get 4 angles in a row that land you on either the positive side or the negative side. So we end up with a bunch of terms here that don't follow a clear, predictable pattern that we can actually get a formula for that tells us when our terms are positive or negative. This is not an alternating series. It's not even what you might want to call maybe a pseudo-alternating series. A series, if you had, as I said, if you had 3 negative, 3 positive, 3 negative, 3 positive, all the way down, you could actually treat it like an alternating series. This is not even that. It doesn't even satisfy that requirement.